5.2 Day 2, Properties of Quadratic Functions in Standard Form. The essential question, how can I identify and use maximums and minimums to solve problems? Please write that down. Substituting any real value of x into a quadratic equation results in a real number. Therefore, and I highlighted this, the domain, so think about it this way. Let's go like this. The domain goes with the x's and the range goes with the y's. So the domain of any quadratic function is all real numbers because it doesn't matter. You can use any x you want and it will work. However, the range of a quadratic function depends on its vertex and the direction that the parabola opens. So when a parabola opens upward, the y value of the vertex is the minimum value. Makes sense because here's the vertex right here. It's the lowest point. Again, the domain is all real numbers, but the range is going to be y is greater than or equal to this k value because the branches are going up. Over here, when it's a maximum, it's the highest point. So when it's a sad parabola, it's a maximum. And here the range is y less than or equal to this k value, because think of a range are your y values. We talk up and down. If my arms are heading down, y is going to be getting smaller than k. The minimum or maximum value is the y value at the vertex. So whenever I ask for that, I don't want the whole ordered pair, which is the vertex. I just want the y value. Example number 1. Consider this function. Determine whether the graph opens upward or downward. So this is very similar to the last video. Well, I'm going to review. A is 1, B is -6, C is 3, just to review with you. I know the graph opens up because my A value is not negative, it's positive. The axis of symmetry, because it's in standard form, is x equals -b over 2a. So we have -b. Notice when I substitute in the a and the b, I put it in parentheses, which is 6 over 2, which is 3. So my axis of symmetry is x equals 3. We'll recall that the axis of symmetry, because that is a line that cuts the parabola right in half, the axis of symmetry goes right through the vertex. So that means the vertex, the x value of the vertex, is the axis of symmetry. To find the y value, I'm going to plug that into the function. Let's do that over here. So 3 squared. Anytime I plug in 3 for x, I put it in parentheses. And think of PEMDAS, left to right, 9 minus 18. There's the y value. Plug in the x, which is the input, and get an output. Now the y-intercept, remember the y-intercept when it's in standard form is just your c value. But if you forget that, remember a y-intercept, we've talked about this a lot, is a point on the y-axis. So that means that your x value is 0, and we're trying to find what y value makes that happen. So if I plug in 0 for x, I get 3. So if you forget that when a function is in standard form, a quadratic function is in standard form, if you forget that the y-intercept is the c value, you can always find a y-intercept by plugging 0 in for x, because that's the definition. A y-intercept is a point on the y-axis, and x is always 0 at all of those places. Let's graph the function. Okay, so our axis of symmetry, let's see if I can do this. It's x equals 3. There. My vertex is 3, -6. 1, 2, 3, 4, 5, 6. Right there. Okay, so that's 3, -6. My y-intercept, we said, was 0, 3. And remember, the axis of symmetry cuts the parabola in half. So that means if my y-intercept is 3 units to the left, 1, 2, 3, I can find another point 3 units to the right of the axis of symmetry. 1, 2, 3, because the axis of symmetry cuts the parabola in half. Oh boy, let's see if I can do this. I'm going to change colors so we don't. Comes down here and through there, and there we go. Okay, now find the minimum or maximum value of the function. Well, remember, it's a minimum because the graph is a upwards. It's a happy parabola, and the minimum is equal to the y value, which is -6. And that's all you need to say. It just wants the y value. Domain and range. Domain, we already said, is all real numbers, or you can write it like that. And the range, y, is going to be greater than or equal to -6. Because the lowest, remember minimum, the lowest y can be as -6, and all the other y values are bigger. Example 2, we're going to do in class, and example 3. There's the video questions. Please do those in your notes.